Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear students, I hope you are fine. Our today's topic ellipse, which is chapter number 6b. Today I want to discuss about ellipse, which is chapter number 6b. First one is definition of ellipse. Here, look at this. If on a Cartesian plan, a point moves in such way that the ratio of distance of that point from a fixed point and a fixed line on the same plane is constant, and the value of constant is less than 1, then the locus of the point is called an ellipse. That constant is called eccentricity, which is denoted by E, where 0 less than E less than 1. Look at this. Here P is the moving point and here S is fixed point on fixed line, and here SP by PM equals to E. Here we can write SP by PM equals to E. Here E is the constant of ellipse and where 0 less than E less than 1. And look at this. Here C is the center of ellipse, and 2 points A and A prime that lies on the ellipse is called vertices, and here S and S prime, 2 points S and S prime lies on the ellipse is called foci, and here look at this. X prime, this horizontal line is major axis, and here y prime, this vertical line is minor axis, and here L prime and L1 prime is the lattice rectum, and look at this. Here MZ and M prime Z prime, these are directrix of ellipse. Now from this figure we can write the standard equation of ellipse. Here standard equation of ellipse. From this figure we can write here x square by a square plus y square by b square equals to 1, where a greater than b. Now from this figure we can write some formula is here. Formula number 1, eccentricity, it will be E equals to square root a square minus b square by a, and our formula number 2, coordinates of center. Here coordinates of center of ellipse, it will be C 0, 0, and formula number 3, it will be coordinates of two foci. Here it will be plus minus AE, 0, and formula number coordinates of two vertices. Coordinates of two vertices, it will be plus minus A, 0, and coordinates of two foot points of directrix, it will be plus minus A by E, 0, and here coordinates of two terminal points of minor axis, it will be 0 plus minus b, and here now formula number 7, coordinates of terminal points of lattice rectum, it will be here plus minus AE, plus minus b square by a. Formula number 8, it will be equation of major axis. Here y equals to 0. Equation of minor axis, from this figure we can write here x equals to 0. Formula number 10, equation of lattice rectum. Equation of lattice rectum, it will be x equals to plus minus a e. And here formula number 11, equation of directrix, it will be x equals to plus minus a by e. And formula number 12, length of major axis. Length of major axis, it will be twice a, and length of minor axis, it will be twice b. Dear students, these are the very important formula for ellipse, and which is very helpful for our mathematical problem. Now we can solve some mathematical problem. Our first mathematical problem is question number 4. Solution given 9x square plus 16y square equals to 144. Now we can divide by 144 from both sides. So we can write here 9x square by 144 plus 16y square by 144, and here 144 by 144, so it will be 1. Now after calculation, it will be x square by 16 plus here it will be y square by 9 equals to 1. So we can write here x square by 4 square plus y square by 3 square equals to 1, which is equation number 1. Now comparing this equation, comparing equation number 1 with x square by a square plus y square by b square equals to 1. So we get here a square equals to 16. So a will be 4 and b square equals to 9. So therefore b equals to 3, where a is greater than b. Now if E is the eccentricity, then E equals to, all we know that the formula of eccentricity, it will be, here we can write a square minus b square by a. So here a equals to 4 and b equals to 3. So putting this value of a and b, it will be 4 square minus 3 square by 4. So we can write here 16 minus 9 by 4. 16 minus 9, it will be 7. That means root over 7 by 4. Here eccentricity is root over 7 by 4. Now we can find out the coordinates of foci. So we can write here the coordinates of foci equals to the formula of foci. It will be plus minus AE comma 0. That means it will be plus minus here A equals to 4. So we can write here 4 into E equals to root over 7 by 4. So root over 7 by 4 comma 0 equals to our answer. Our required answer is plus minus here 4 and 4, it will be cancelled, and after calculation it will be root over 7 comma 0. This is the result of foci. And again we can find out the value of the length of lattice rectum. So we can write here, and the length of lattice rectum equals to 2b square by a. 2b square by a. This is the formula of length of lattice rectum. So now we can put the value of a and b. So it will be 2 into here b square. B square equals to 9. So we can write here 2 into 9. A equals to 4. So A equals to 4. After calculation it will be 9 by 2 unit. 9 by 2 unit. Look at this. This is the required solution of question number 4. Now question number 10. Find the eccentricity of 3x squared plus 5y squared equals to 1. Solution. Here given 3x squared plus 5y squared equals to 1. So we can write here x squared by 1 by 3 plus y squared by 1 by 5 equals to 1. Again we can write here x squared by 1 by root over 3 whole square plus y square 1 by root over 5 whole square. Look at this. 1 by 3 equals to 1 by root over 3 whole square. They are same. So we can write easily. It will be 1, which is equation number 1. Now comparing equation number 1 with x squared by a square plus y squared by b square equals to 1. We get, look at this, after this line we can write here a equals to 1 by root over 3 and b equals to 1 by root over 5. where A is greater than B, where A is greater than B. If eccentricity is E, if eccentricity is E, then we can write E equals to here A square minus B square by A square. So E equals to here A square A square equals to 1 by 3 minus B square equals to 1 by 5, and here A square 1 by 3. Now we can calculate. Here we can apply LCM method. 3 into 5, it will be 15. So 15 divided by 3, it will be 5, minus 15 divided by 5, it will be 3. Here 1 by 3. So we can write here, after this line, here 2 by 15, 1 by 3. So we can write 2 by 15 into 3 by 1. After calculation, it will be 5. That means square root 2 by 5. Now question number 11. Solution. Here, for which value of P the ellipse x square by P plus y square by 5 square equals to 1 passes through the point 6, 4. Find the eccentricity and the position of foci. Given, we can write here x square by P plus y square by 5 square equals to 1, which is the equation number 1. Now we can write here equation number 1 passes through the point 6, 4. So we can write the equation number 1 passes through the point point 6, 4. We get here. So we can write here 6 square by 5 plus 4 square by 5 square equals to 1. Here we can write 36 by P. After squaring, it will be 36, and 4 square it will be 16, 5 square it will be 25 equals to 1. Again we can write here 36 by P equals to 1 minus 16 by 25. Now after this line we can write here 36 by P equals to 25 minus 16. After calculation, it will be 36 by P equals to here 25 minus 16. It will be 9 by 25. So now we can apply cross multiplication method. So it will be 9p equals to 36 into 25. Here p equals to 36 into 25 divide 9. So here 4. So p equals to, after calculation, p it will be 4 into 25. So we can write here 100. So p equals to 100. Now putting the value. Now putting the value of equation number 1. So we can write putting the value of p equals to 100 in equation number 1. In equation 1, we get after this line, it will be x squared by 100 plus y squared by 5 square equals to 1. So we can write x squared by 10 square plus y squared by 5 square equals to 1. Now comparing this equation, therefore comparing the equation with x squared by a square plus y squared by b square equals to 1. We get here a square equals to 100. Therefore a equals to 10 and b square equals to 25. So b it will be 5. B it will be 5. Look at this. Here a equals to 10 and b equals to 5. So obviously a is greater than b. So we can write here where a greater than b. Now find out the value of eccentricity. So if E is the eccentricity, then E equals to, we can write a square minus b square by a square. Here look at this, a square equals to 100, b square equals to 25. So we can write here 100 minus 25 by 100. After calculation it will be 75 by 100. So we can write here 75 by 100, it will be 3 by 4. After calculation it will be root over 3 by 2. Look at this, here E equals to root over 3 by 2. Now this is the result of eccentricity, and now the position of forcing. So we can write here, therefore the position of forcing it will be plus minus AE, 0. That means here plus minus A equals to 10, and E equals to root over 3 by 2. So it will be root over 3 by 2, 0 equals to, we can write here 10 divide 2. So it will be plus minus 5 root over 3, 0. which is the required solution of question number 11.